So again, you need zeros, you need behavior. Share your graph with each other. Make sure you guys agree on it. All right, so how do I go about graphing polynomials? Molly, what would you do first? Okay. Good. So Molly's saying degree and behavior. So I'm in what degree is it? I don't think 5. I think you're going in the wrong direction. Isn't it 6? Right? Isn't that a 6? If I multiplied it all out, wouldn't it be a 6th degree polynomial? Right? Is that okay? So, Julia, how about leading coefficient? Positive or negative? Leading coefficient. Positive. So, positive leading coefficient means right-hand side goes up. The degree being even means it matches. Right? So, Molly started us with end behavior. What would we do after that, Ella? Zeros. What are the zeros? Good. So if I factor that, it can factor 2. Whoops, I put an I and a plus altogether. Right? It factors to x plus I, x minus I, x plus I, x minus I. Right? So that's what that factors to. So I can't put any zeros on that. Evelyn, what should I do to the zeros? Good. So any weird behavior going on? Yeah. Change it. Yeah. All right. So that's all I need. So now I'm going to connect the dots. I'm going to pass through -1. I'm going to be tangent to 3. I'm going to pass through 4. So does anybody know what the positive I and negative I do to it? What does the positive I and negative I do to the graph? Or does it do anything? Changing concavity where? You actually don't, right? You need calc to determine where the concavity will change for your complex zeros, okay? So that's what the complex zeros do have in the graph. They're going to change the concavity somewhere. That graph, that red graph, is a perfect graph to do a model of, because the only thing that's going to change is concavity, okay? All right, so what I want to ask you is, where is this function greater than 0? Where is it less than 0? Where is it equal to 0? So where is it greater than, less than, equal to? So then what am I going to look at for equal to? Look at the zeros, so -1, 3, and 4. Do you think I need to list the 3 twice on this one? Right? I don't, right? I'm just asking you when it's 0. Okay? Caitlin, how about greater than 0? What do you think? Greater than 0. Order of infinity. Should they be both open, closed, what? Open, because it's just greater than, it's not equal to. And then Dakota, how about less than? Are you guys okay with him saying -1 to 4? Right? Why not, Charlie?
Because it's tangent of 3, so it's -1 to 3 on the tangent.
Is that okay, Dakota, right? Because 3, he said tangent, I'll say equal to, right? It's equal to 3 at that point, so it's not less than, so you're going to go -1 to 3. Right? Is that good? All right. So I could do this in a different way. We haven't had this lately. We haven't had sign graphs lately. I missed them. -1, 4, 3. Whoops, wrong location. 3, 4. So remember what a sign graph is. What we're really doing is we are taking a number in each of these sections, we're plugging it in, and we're seeing how it behaves. But remember, we can do that very easily with a sign graph. So if I do a sign graph for x plus 1, positives to the right of the -1, negatives to the left. If I do a sign graph for 4, positives to the right, negatives to the left. What do you think about a sign graph for the 3? X minus 3 all squared. Austin, what do you think then? It's all positive, right? So I could put all positives. And then how about a sign graph for x squared? Well, x squared plus 1, right? All positives again. So I asked you for the least number of limit lines in your quiz. What if I asked you for least number of sign graphs? What colored sign graphs are needed? What color are not? So I got red, I got yellow, I got green, I got purple. Which ones aren't needed? Everybody's saying? Green and purple, right? So let's try to do least number of sign graphs. Let's see if we get the same answer. So when something's all positive, I really don't need that. Negative over, or negative times a negative is positive. Positive times a negative is a negative. Positive times a negative is a negative. Positive times a positive is a positive. So those results of the sign graph equal the results of the graph that I drew. Is it the same thing? Is it positive from -infinity to 1 and 4 to infinity? Is it less than on those two locations? Right? Exactly the same. Is it going to change when I make it a rational function? Right? So again, polynomial, showed you how it matches the sign graph. Now I took it and I changed it to a rational function. That's what we're coming off of, right? So let's build it as a rational function now. Okay, rational function. So what are our x-intercepts now? What are our x-intercepts? What do you think? X-intercepts? -1 and 4. Right? So this time I only have 2. -1 and 4. How about vertical asymptotes? Vertical asymptotes. 3 only. I'm actually going to change that guy to my vertical. And I'm going to change 4 is that. All right. How about y-intercept? Y-intercept. Right? We usually said constant over constant, but it's not multiplied out. So if I plug in 0, plug in 0, plug in 0, plug in 0, plug in 0. So what? -4 over 9? -4 nines. All right, what's the last thing I need to do? Actually, 2 more things to do. We did vertical asymptote, so, and behavior asymptote, right? So what category is it? Kyle, what category is it? Less than, equal to, or greater than?
No, it's like
Denominator is greater than numerator. So our end behavior asymptote is at 0, right? End behavior asymptote at 0. Totally okay that it crossed it. So, Caleb, what am I going to do to figure out around the vertical asymptote? So what am I at? I'm at 3. So 2.99 and 3.01. 2.99, 3.01. So let's again be efficient. Noel, how about the denominator in both of those? Denominator, denominator. Always positive, right? So look for that. Look to see if something's not going to matter what we're plugging in. All right, 299. Enzo 299, positive or negative?
Positive. Negative.
So negative, right? So on the left-hand side, it's going down. Yeah, how about 301? 301, 301. Positive, negative again. So on the right-hand side, it's also going down. Do you think you know your graph? Think you know your graph? Do you have enough? The y-intercept. Y-intercept, right? I plugged in 0. Do you know your graph? I think you do. I think you have enough info. Doesn't it do this? Crosses, needs to reapproach. So what? There's going to be a local max there, right? Crosses and reapproaches again. Another local max. I don't know which one is higher, so I don't know which one's absolute, right? One of them's absolute, but I don't know which one. Is that the same answer to our previous page? Is that our same answer to the previous page? Look at where it was greater than, right? Look at where it was greater than. It's greater than from negative infinity to negative 1 and 1 to 4. Is that the same place it was greater than? I think it was, right? And Aria, how about less than? Was it less than from negative 1 to 3 and 3 to 4? It was, so it's the same. So what's the only thing that's different? The zeros, right? 3 is a restriction on the domain now, right? And the zeros are only negative 1 and 4. So we just kind of did the same problem 3 different ways. We did it as a polynomial, as a sine graph, as a rational function. Fourth way, will a sine graph, when it be an irrational function, be any different? So let's look, right? Zeros are the numerator, and I could close it because if it's equal to 3 is the vertical asymptote, so that's in the denominator, that would always stay. So if I do a sine graph for negative 1, it's in the numerator, so I like to write it on top. Sine graph for 4 in the numerator, so I like to write it on top. Sine graph for the denominator, do I need any? Squared and I. I don't need any, right? So it's always positive. So let's look. Positive, negative, negative, positive. Same answer, right? So I did it as a polynomial, got a graph, answered it. Did a sine graph for that polynomial, same answer. Is the sine graph for the polynomial the same as the sine graph for the rational? Does it matter that it's a polynomial or a rational function? Right? Austin's saying, no, it doesn't. Does the graph look different? Sure. It's a different function. It's a rational function. Which way is the easiest? Sine graph for poly, sine graph for rational, graph your rational, or graph your poly? Which way is the easiest? I think sine graph's the easiest, right? Because you're really just doing positives and negatives. I don't care which way you do it. I don't care if you graph the rational function and you decide, or you do a sine graph and decide, or you graph the poly and decide, right? But if you're choosing graphing, you have to graph it like a poly if it's a poly, graph it like a rational if it's a rational, right? But the sine graph, I think, is so much easier. So that's what we're practicing today. We're practicing some of the sine graphs. Okay, so really what we're doing is we're doing inequalities. We're looking for it to be less than, we're looking for it to be greater than, and we're looking for it to be 0. Okay, I'm going to flip a couple of slides. I want this one. Right, so do I have a rational function on that first one? Is x plus 2 over x squared minus 9 rational? It is, right? Poly over poly. So the first thing you want to do is you want to try to factor it. So all I need to do is factor the denominator. We're going to look at, are there any holes? There's not, right? And then I want greater than 0. So as long as you have a 0, you're good to go with a sign graph. If it's not a 0, you need a 0. Okay? So Henry, where should I put my kind of sections on my sign graph? So positive and negative 3, and then negative 2. Are any of them weird factors? X plus 2, x plus 3, x minus 3. Are all of them kind of normal factors? Any multiplicities, right? Nothing weird going on. So they're all normal. So what I like to do is I like to first look at the sign. It's greater than, it's not equal to. So I don't care where the zeros are in the numerator or denominator, they'd all be open, right? If it's equal to, it would change. So now they're all normal factors. So I'll do a sign graph for the negative 2. Again, it's in the numerator. Doesn't really matter where it is, but I like to keep it up top. I'll do a sign graph for the 2 3s, right? They're below. So I'll do those. And then I'm just going to look at multiplying them all. So negative, positive, negative, positive. So I need greater than 0. Greater than 0. So write your answer for greater than 0. Greater than 0. Make sure you're doing brackets or parentheses. Caitlin, what do you think?
Negative 3 to negative 2 and 3
Good. Okay. So nothing weird is going on there. All right, let's take this one and let's change it to an equal to. So why don't you guys factor it, see if there's any zeros, try to set up your sign graph, and then answer it for greater than or equal to. Greater than or equal to. Number 2. Right? So it was greater than, but I'm changing it to greater than or equal to, just so we have like kind of some equal to's as well. Again, if you want to draw it like a rational, you totally can. I just think sign graphs are so much easier. Let's add in this one least number of sign graphs. Least number of sign graphs. See if you can do that. Check with each other, see if you agree. A lot of people tend to put a 0 on your number line. I would suggest against that unless it's a 0. Right? So you don't need a 0 on your number line. You know it should be in order from lowest to highest. I think if you put a 0 when it's not present, you think it's a section and it's not. Chat with each other. How many sign graphs do you think you need for this one? How many sign graphs? Least number of sign graphs. But the purpose is you don't really have to put them up, right? The purpose of a normal sign graph, x minus 5, x plus 5, because it's always possible. So we're trying to do it. They'll change a little. All right, do you guys agree with my closed and open? Right? Is my closed and open good? So why is 2 open this time? It's tangent, but another reason why for this one not tangent on this one when it's a polynomial, it's a vertical asymptote, right? It's a restriction on the domain. So, Austin, how many sign graphs do you think? So which one do you not need it for? Right? So x minus 2 all squared is always positive. So I need a sign graph for my 4, a sign graph for my negative 3. So I've got positive, negative, negative, positive. If you want to write, like, I like to just circle them, and if it's not there, write it, right? So we're looking for greater than or equal to 0. So are you guys okay with negative infinity to negative 3 close 4 to infinity? Is that okay? Greater than? Because it's a negative times a negative is a positive. I don't think so. Do you agree with 2 sign graphs, or did you do 3? Okay, so you can do 2. You can't do 3, but you could do 4. Why would you do 4 if you wanted to? 1 plus 2, so that's what you didn't do, right? So Caleb's saying he did 3. If he wants to do as many sign graphs as possible, then he's going to need 2 for each 0, right? Because isn't something always squared positive? Does a positive affect a sign when it's positive and negative, right? So that's why I'm saying least number, because it just makes it less confusing, right? Just makes it less confusing. All right, let's do last one. And again, least number of sign graphs, and again, we're going to make it equal to least number of sign graphs. Least number of sign graphs. Least number. Should I put the 0 on the number line, even though I don't need a sign graph for it, the 3 on the number line, even though I don't need a sign graph for it? Should I still put it on the number line? Right? Why? Why should I do that? You're totally right. I should. Right? I don't need a sign graph for 0 because it's always positive. I don't need a sign graph for 3 because it's always positive. I do need a sign graph for negative 4, and it's just a normal sign graph. Especially if it was just less than, right, and it wasn't equal to, I have to make sure I'm doing every single section. So I probably should have kept it a less than, right? So let me answer it with the less than. Wouldn't the less than just be negative infinity to 4 open, right? If it was just less than. When I changed it to equal to, well, a 0 and a 3 make it 0. So I have to go union 0, union 3. I'm fine with you just having numbers like that. Sometimes you'll see the book answer, put it in brackets on its own, or you might even see like the little curly brackets. I just like the numbers themselves. They would be, yeah, they're zeros. So they're zeros, so it doesn't matter if they're tangent or cross. You're right, they would be tangent, but that is only going to affect of whether it bounces up or bounces down. But I'm looking for it to equal 0 as well, right? I had stuck an equal sign in there. So I do need to keep them as zeros, because they do make that inequality true. They're equal to. Is that okay, Henry? Like, look at how quickly we did those 3 problems with sign graphs. It'd be a little more with graphical, right? That's kind of why I like the sign graphs. All right? 3 more. Actually, we're like 5 more, but we'll do 3 first. Okay, so there's 3 of you. So look at the different things I have here, right? I have some i's. I have an absolute value. I've got a radical. So somebody decide to do 4, somebody decide to do 5, and somebody do 6. So somebody do each one. You got to factor it, you're going to do a sign graph. Because again, you probably did that one last, right? So you probably didn't realize it didn't exist until you got there. Charlie, wait in here, right? You're losing valuable math time there, just holding up the wall. All right, so when you and your group are done, right, I want you to flip your notebooks, right? Rotate your notebooks. And each person needs to look at each box. So you're going to rotate it once. Then you're going to rotate it again. And you're going to see if they are correct or not. I know you're going to have to understand.
Oh.
All right, so check their problem.
Someone's walked in. So I gotta wait there.
Make sure they factor it correctly. Oh, wait.
Oh, I
So if there's an error, you should fix it for that person and then rotate one more time and it should be correct at that point.
No idea.
We do have a whole lot of right? That's why it makes sense. If you need to find, so this one,
Yeah.
yep, so you got how much time do we have?
All right, so did everybody switch? So what I want you guys to do now, okay? So these three groups, you're gonna get together and you're gonna agree on an answer for 4. One of you are gonna put up the sign graph on the smart board. And then I was gonna say the answers on the whiteboard, but I actually want the answers on the smart board because I'm recording it. People in the middle, you guys get together and decide on the right answer for 5. Same deal. One person in one group put the answer, someone in the other group put the sign graph, and then same thing for you guys. You guys are 6, right? So really quick, 1-minute conversation, get up and move, right? You don't have to necessarily move your chairs, but get up, right? And agree, get an answer, and then put it up. I got 2 better ones coming up, so really quick conversation. Whenever you guys agree on an answer, somebody go up with the sign graph, somebody go up with an answer.
Oh, wait. Yeah, no.
Right, so somebody go up to the sign graph, somebody else put the final answer. So 2 people per problem, please.
Should I just put one sign graph?
With however many sign graphs you think you need to solve the problem. So I don't think 1 is okay.
Yeah.
So you gotta do same thing, yeah, same. You can put the answer like when we put it. You just gotta put the answer inside the purple rectangle. Do you guys see why this is not a huge topic, right? Again, like we did polynomials, you could go to the graph. We did rational functions, you could go to the graph. I can take those 2 ideas together now, right, and just answer it with a sign graph. Again, I really think it's nice to put numerator sign graphs on the top, denominator sign graphs on the bottom, right? And then like circle your answer in some way. Do least number of sign graphs. Least number of sign graphs. It makes it less messy. All right, so let's look. Ooh, what's that number, guys?
That's 1.
That's a 1?
The 1 is more to the left. Now I try to erase it.
Yeah, racing isn't good. It's not even a racing.
Scribbled over it. Yeah.
Okay? So, what do you guys think? Charlotte, Savannah, which one we gotta fix? This one says negative infinity to negative 2, 2 to infinity, negative 2 to 1, 1 to infinity, negative infinity to 3 halves, 2 to 5. Why? What's wrong with 6? Why is this part really not part of our answer? Restricted domain, right? So restricted domain, even though the sign graph works for that, I really don't need a sign graph for that because that whole part of the domain is gone. Right? Does that make sense? Right? Because I can't have a negative under a radical. So that whole part of the domain is gone. All right? Try. Is that okay, all of those? Right? I would say 1 sign graph. I'd say 2 sign graphs. I'd even say only 2 on this one. But again, I think you guys did the 3 halves as well. Right? All right, least number of sign graphs. These 2 are better. Oh, they're really ugly. Okay, so I got an absolute value. Actually, you know what? I think I want this one to be less than or equal to. I think that one I want to be less than or equal to. So absolute value of x plus 5. X minus 1 to the 4. Square root of x minus 4. 8 plus x cubed. 9 minus x squared, 11 minus x to the 5th. So I'm just going to go put some sign graphs. You guys are going to try to solve them. And again, I want least number of sign graphs. Least number of sign graphs. What, we got the top equal to? So the top, I'll go close these guys. Open that guy, and on the bottom one, I'll open all of them because it's not equal to, right? That's kind of one thing I like to do first is close and open. Again, least number of sign graphs. That's what I want. Least number of sign graphs. Remember, the first one is less than or equal to, I changed it. Wow. Does that make sense, right?
Yeah.
But is that for the top? And so just blew his mind. What's the first answer, Enzo? No real numbers. How many sign graphs do you need? None, right? Because this is always positive. This is always positive. This is a limited domain, right? So I can cancel this whole part out. And yeah, you could go and put positive, but it's not going to do anything. So do I have any negative sections? I don't, right? If I flipped that rational function, the answer would just be 4, right? Because it would be equal to. Limit your domain. Because the zeros, 1, make the denominator a negative under the radical. So if you ever have a radical in there, right? I tend to do the radical last, but really efficiently you should do it first because you don't have to look at the rest of that. But I don't know, I just like doing it last. I feel like I should do it last. All right, how about least number of sign graphs for the bottom one? Least number of sign graphs. 2. Very good. All right. Which one do I not need 1 for? 9 minus x squared, right? Because always positive, right? And 9 would be open. Negative 8 would be open. 11 would be open. So why are you guys saying only 2? I'm going to guess 1 for each of them. Why don't I need 3? Why don't I need 5? Why isn't it how it works, Austin? Right? If there's 3 of them, don't 2 of them cancel out with each other? Right? So in odd multiplicity, you always just need 1. Does that make sense, right? Because if I had 3 of these guys, right, and it was negative, these 2 are going to cancel out, and I'm just going to have 1 left for the negative. So odd multiplicity, always just 1. So let's see. 8 plus x, that's pretty normal. Just has a multiplicity of 3. Why am I going to say 11 minus x is different? 11 minus x. The x is negative. So think about it. If I took a number over here like 12, and I plugged 12 into there, 11 minus 12 is what? Negative. So when you have a negative coefficient, you can do one of 2 things. You can factor a negative out and then change the direction of the inequality, right? Because that's what you do when you divide by a negative. Or what I like to do, just flip your sign, right? So a negative coefficient, instead of positives to the right, you're going to go negatives to the right, positives to the left, right? A negative leading coefficient. Negative leading coefficient. If it was a negative leading coefficient with a fork, do I need to do that? No, because it would still be positive, right? So odd multiplicity, when it's negative, you gotta flip them. So what's our answer? I lost myself there. So it's less than, so here and here, negative infinity to negative 8, union 11 to infinity. What happens if it was equal to? What happens if it was equal to? What changes? Negative 8 changes, and what? 9 would change, right? So I probably stick a union 9 in the middle there to keep it in order. So that's what this section is about, all of these inequalities, okay? So there's some polynomials in the homework. There's some rationals in the homework. There's some equations. Well, if you're going to get to equations, we'll do one next class. So again, you can do homework tonight. It's not due until Friday. Okay? We are going to start partial fractions next class. Yeah.
So,
Yeah, you just got to give me a second to look at it and digest.